You work for a consumer watchdog publication and are testing the advertising claims of a tire manufacturer. The manufacturer claims that the lifespans of the tires are normally distributed with a mean of 40,000 miles and a standard deviation of 7,500 miles. You test 16 tires and get the following lifespans. Complete parts A through C below. And then here's the table that we're given, and what we're going to do is left click on this link to copy to the table, and we're going to open this in Statcrunch. Let's resize this window so that we can do. Now we'll see that the values are loaded into Statcrunch. This is draw a frequency histogram to display this data. Use 5 classes, choose the correct answer below. So this is a multiple choice problem. So we need to draw a histogram. First thing that we need to do is left click data. We are going to scroll down to sort. We will left click sort. We will take var1, which is our first column. We're going to sort it ascending, and we have a new column. And now everything has been sorted from least to greatest. The problem says use 5 classes, so I need to know what the range is, which I will then divide by 5 in order to get my answer. So we left click stat, we will left click summary stats, left click columns, and then we are going to look for range. Left click range. We'll left click sort, left click compute. And our range is 24,289. You will then divide that by 5 and round up to the nearest whole number, which will be 4,858. Now this is our class intervals. Okay, this, or I should say class width. And remember that our smallest value is 24,533 miles. And this will start the first class. And that's the lower limit of the first class. Now we'll go ahead and use this information to create the histogram in Statcrunch. So we left click graph, scroll down to histogram, and left click histogram. The column that we want to use is the sorted column. We want a frequency histogram. We want to start at our lowest level, which is our lowest value, which is 24,533. The width will be 4,858. Left click compute, and we now have our histogram. And we see that it looks exactly like this one. So we will left click that. We will do a check. And we have that one correct, which is going to bring up our next problem. Now, it says, is it reasonable to assume that the lifespans are normally distributed? Why? Choose the correct answer below. Well, in order for a graph to be, or a distribution to be normally distributed, the mean and the median should be equal, or roughly equal, and we should have a general bell-shaped curve. And this one does give us a bell-shaped curve, so we're going to look for that in here. It's a symmetric graph and it's bell-shaped. Yes, because the histogram is neither symmetric nor bell-shaped, that doesn't work. Yes, because the histogram is symmetric and bell-shaped, and that is our answer. We left click, check answer. Go to the next part. The next part says the mean is. Once again, I want to use Statcrunch for this, so I'm going to return to my Statcrunch window. And I don't need the histogram anymore, so I can go ahead and left click the X and get rid of it. I'm going to keep the range, however, because I may need it at some point. So in order to find the mean, we will left click stat, and we will go to summary stats and left click columns. Now, this is a sample. Okay, we're testing 16 tires and getting the following lifespan. So we left click sort, which is the one that we we're going to use since it is sorted, and we will left click mean and simply left click compute. And that gives a mean of 36,712.125. Notice that the blue here says round to 1 decimal place as needed. So we left click in the answer field, and we are going to go ahead and type in 36,712.1. And we left click check answer, and we're done with that part. Left click OK, and then it says find the standard deviation of your sample. The standard deviation is, here's our answer field, and we will round to 1 decimal place as needed. Once again, I will return to Statcrunch. I will left click stat, left click or highlight summary stats, and left click column. Once again, I will choose the sorted column, and I am looking at the standard deviation of a sample. This right here is the standard deviation selection for a sample. In the future, if you have to do a standard deviation of a population, you will choose unadjusted. But for right now, we're doing a sample. We left click that, we left click compute, and our standard deviation is 6,115.2573. We will round that to 6,115.3. And we've checked our answer, and we have calculated the correct standard deviation. Now, compare the mean and standard deviation of your sample with those in the manufacturer's claim. The sample mean is less, and let's look at that for a moment, because in this particular problem, we're given the claim by the manufacturer, and the claim states that the mean actually we'll go ahead and use mu for that, since the manufacturer is talking about the population. So the mean is equal to 40,000, and the standard deviation is equal to 7,500. In our calculations, x bar is equal to 36,712.1, and the standard deviation s is equal to 6,115.1. I'm sorry, 0.3. So we need to compare this. The sample mean is less than the claim mean. That is true. So on average, the tires in the sample lasted for a shorter time. The sample standard deviation is greater than the claim standard deviation, which was not true. And in fact, if we look at this carefully, we see that the mean that we calculated from the sample is less than mu. So we can say that x bar is less than mu. And we can also look at the standard deviation, and we know that the standard deviation of the sample is less than the standard deviation of the population. So we look at all three of these. Part B says the sample mean is less than the claim mean. The sample standard deviation is less than the claim standard deviation, so the tires in the sample had a smaller variation in lifespan. Or part C, the sample mean is greater than the claim mean, so on average the tires in the sample lasted for a longer time. A and C are clearly false, so B is our only choice, so we left click B and we left click final check, and we have finished the problem. Now let's understand exactly what's going on here. Because the standard deviation is smaller for the sample than it is for the population, it follows that the variance has to be smaller. Likewise, since the mean is smaller in the sample than it is in the population, these tires do not last as long as the company's claims.